Okay. So remember to get your vertex. You have your vertex formula. X is equal to, what have I done? There we go. Negative b over 2a. Then you get your x and you plug it in, right? So if we're doing problem 1, then I have f of x is equal to negative x squared plus 10x. And my b is 10. So negative 10 over 2 times negative 1 gives me that x is equal to 5, right? So I've got that. And then I need my y. Well, all I gotta do is plug that in. So negative 5 squared plus 10 times 5. Be careful on that negative. If, because this is outside of that parentheses, it's going to stay a negative 25 plus 50. So that gives me 25, right? And that answers a lot of questions right there. What is my axis of symmetry? That's always the x, right? So I would, for the axis of symmetry, I would say x is equal to 5. What if I asked you about the domain and range? What's the domain of any quadratic? You would, if you're solving it, you're going to put y equals to 0, but what would the domain, what would x include? Remember, any quadratic has a domain of all real numbers because it's a parabola that's going to continuously get wider and wider. And what, remember, domain's your x and range is your y. So what would my range be on this one? Do I have a minimum or a maximum? Am I concave up or am I concave down on this one? Down, right? So that means I've got a maximum. So that means that my y is going to go up to 25, but then it's going down to negative infinity. So my range is the set of y. Y is less than or equal to 25. What would my y-intercepts be on this problem? How do you find your y-intercept? Who has to be 0 if you're looking for the y-intercept? X is 0. So if my x is 0, then I have 0 plus 10 times 0. So my y-intercept would be 0, 0, right? What would my x-intercepts be? Another 0, 0. If I factored that out, I'd have x times x plus 10. So 0, 0, and negative 10, 0. Be prepared to answer any of these questions for any one of the problems that you get, and almost all of those problems, you are gonna have to find the vertex. To answer those questions, you've got to find that vertex. What would your vertex be on problem 2? I'm getting the vertex on problem 2, that's your study guide. Mhm. You brought me dinner, how'd you know I was so hungry? Yay! Study guide there. So that would be a -4/2 times 1, giving me x is equal to a -2. Now, this is what I was talking about. This problem here, you've got the negative on the x in the function, right? Believe it or not, it's not the whole algebra thing, it's those dadgum negatives that get us in the wrong answer. Because this x was on that negative there, that changed, that stayed as a -25, right? Because there's just one negative and 2 x's. But this one is different because x is the -2, right? So this time, when I do plug it in, I'm gonna have -2 squared plus 4 times -2 plus 3. So I've got 4 minus 8 plus 3 gives me a -1. I hope you guys are checking my math. And remember, this is getting my y. So my vertex is -2 and -1. Make sure you are able to get your vertex, guys, because I promise you it will be in several problems. I'm not asking you about the vertex, not directly what is the vertex, but when I ask you for axis of symmetry or when I ask you for the range, you're gonna have to be able to give me that x and y. So for problem 4 and 5, we need domain and range. And again, what's the domain of any and all quadratics? All real, right? So that's the easy one. But the range, I need that vertex. I need to know what the Y is. I need to know my lowest or highest point. Those of you at home, there are paper copies of the study guide in my mailbox on second floor in the copy room if you want to pick one up. So my vertex for 4, I've got 10, negative 10 over 2 times 1. So x is a negative 5. Again, that's going to be negative 5 squared plus 10 times negative 5 plus 25. So I've got 25 minus 50 plus 25, giving me a 0. Negative 5 and 0. My A is a positive 1, so I know that I am concave up. This is my minimum point of negative 5, 0. So I have the range of y such that y is greater than or equal to 0. Domain, all real. Yes? This is a negative 1 on here, so I'm concave down. So when I do my range, it's going to be less than, and I've got a negative 2 over 2 times negative 1. So that gives me that x is equal to negative 1. And when I plug that in, negative 1 squared minus 2 times negative 1 plus 3 -1 plus 2 plus 3, that's gonna give me a 4. So my vertex is -1, 4. So up here, I'm at the point of -1, 4. So my domain, all real, and my range is less than or equal to 4. Given a point, what does my vertex form look like on my equation? Right? H and K being the vertex. So if you are given the vertex and told to write the polynomial, we have the vertex of -1 and 1. Right? So -1 is my H, and 1 is my K. So I have X minus -1 squared plus 1. And if I FOIL that out, X minus or plus 1 times X plus 1 plus 1, I'm going to get X squared plus 1X plus 1X plus 1 and another plus 1. Cleaning it up, I get X squared plus 2X plus 2. Now, what about that I ended up with gave me some assurance that I have the right polynomial? What else do you see on that graph? What other information did I give you on that graph? The y-intercept, and the y-intercept is 2, right? All right. I'm going to give you a minute to look at 7 and 8. Your minimum maximum value, that's going to be your y. But again, what do you got to have? Where did what now?
I was on with it.
Oh, problem 8, I'm sorry. This was 7. If I have 1/3 squared, that's a 9. Times a 3 takes me right back to 1/3. And supposed to be a minus. 2 times 1/3 gives me a minus 2/3. Minus 3/3, that's my 1. So that's gonna end up with y is equal to 4/3. So my vertex, 1/3, 4/3. Is this a maximum value or a minimum value? How do you know? That's positive, right? If I have a positive A, this is 1/3, 4/3. So your answer to this would be y is equal to 4/3. Okay. 9 and 10, how are we on the inequalities? Questions on those? When it comes to the inequalities, you have to factor. You need to know what your x-intercepts are. So if I have x squared minus 6x plus 8 is greater than 0. So all I gotta know is where is this gonna cross the x-axis? So what can multiply to get an 8 and add to get a negative 6? Minus 2 minus 4. So that gives me the x-intercepts of 2, 0 and 4, 0. So when I'm looking at this on my graph, the only thing I need to know is this 2 and this 4, and that my A here is positive, because I just need to know where I'm above and where I'm below that x-axis. So since I'm looking for above, I want to know what that answer is. This is the one that has a break in it, right? So we got to use that union symbol. So we're going from negative infinity to 2. And I'm using parentheses because I do not have the or equal to. Union 4 to positive infinity. And remember, if this had been f of x is, instead of greater than, less than, or equal to 0, then I would be looking for this section right here. If it's less than or equal to, and then I would have had 2, 4. Right? Watch your symbol. Okay? What do I have to have in order to be a polynomial? All exponents must be positive integers. So if I'm looking at problem 11, I have f of x is equal to negative 11x to the 4th plus 7x to the 3rd plus 4. I have a 4, a 3, and a 1 for exponents, right? They're all positive integers. So that says, yes, that's a polynomial. The degree is 4. What about 13? I have f of x is equal to x to the 4th minus 6 over x to the 6th. That x to the 6th down there in the denominator, rewritten, this is x to the 4th minus 6 times x to the negative 6. My exponent is negative, so it's not a positive integer. That's a negative integer, so that would be a no, right? Sometimes you're going to have to work them out. I think on your quiz that you had on chapter 5, you had something like f of x is equal to the square root of x. I want to say it was a -5. This isn't on your study guide. This was a problem we had on that quiz, something like this anyway. When I distribute that, I do get an x there. So that's x to the 1st power, and that's fine. But that would be -5 times the square root of x. How do I write the square root of x with an exponent? This is the same thing as x minus 5 times x to the 1/2, right? Not an integer, not an integer. So this would have been a No, that's not a polynomial. All exponents must be a positive integer. Questions on that before I move on? Anybody at home? Mhm.
Degree.
Do what?
For when it asks if it's degree.
Okay, so this one, you wouldn't say the degree because that's a no. If it's a no, you won't be giving the degree. The degree is always the highest exponents. The degree is whatever the greatest, like, 12 would be 2. Because you'd have to distribute that x. Yes, ma'am? A no, because that's not an integer, right? Anywhere? Before I move on. All right, if I look at 15, my zeros, which are just another name for, what are zeros just another name for? Those are my x intercepts. So now we've already done some of this when we wrote from problem 6. When we wrote, we have our polynomial already. We have x plus 3 from that negative 3 and x plus 1 from that negative 1 and x minus 2. Right? Now all I got to do is I got to start foiling it all out. I just got to multiply through and find out x squared, 1x, 3x, and 3. So if I clean that up, I get x squared plus 4x plus 3. And then I have to multiply that by that x minus 2. And that's going to give me x to the third plus 4x squared plus 3x minus 2x squared minus 8x minus 6. Clean that up some more. I have f of x is equal to x to the third. That's that one. I have a 4x squared and a minus 2x squared, so that's plus 2x squared. Took out those two. I have a 3x and a minus 8x, so I have a minus 5x minus 6, right? You're just working it backwards, just like you would for any quadratic. I give you the solution to the quadratic equation. You can work it backwards and tell me what the equation is. Nothing different here. What does multiplicity mean, guys? I have a 0 of 2 with a multiplicity of 2. What do I write for that? Minus 2, because that's a positive 2 here, to the second power. That multiplicity puts an exponent on your binomial. And then I have a 0 of negative 2 with a multiplicity of 2. So again, now I'm going to have x plus 2 squared, right? Foiling it out and you will get to your polynomial. What about my x and y intercepts? If f of x is equal to x plus 4, x minus 5, and x plus 5. They're showing me my x-intercepts, right? F-intercepts and zeros. Two words, same thing. My x-intercept, -4, 0, 5, 0, and -5, 0, right? We have to set each one of those equal to 0 and then solve. What about my y-intercept? I'm looking for the y-intercept, who's 0? If I'm looking for the y-intercept, x is 0, right? So if my x is 0, what is my y going to equal to? A -100. So 0 and -100. I'm looking, questions before I move on to problem 20? None, huh? Okay. If I'm looking at problem 20, and it's coming through here. I know this is 0. This is 1. And this is 2. First of all, how many turning points does this graph have? How many times does this graph turn? So that tells me 3 turning points means that I have a degree of 4, right? So right there, I might not know which one is, but which one is not? Which of these quadratics, or these polynomials down here, A, B, C, and D, has a degree that's not 4? If I have x squared times x minus 2 squared times x minus 1 squared, what's my degree on that one going to be? When I get done multiplying here, I'm going to have an x squared out of this, right? And then that's going to give me an x to the 4th. And then I'm going to have another x squared out of here, and that's going to give me an x to the 6th power. So D I can knock out. Because I know 3 turning points means a degree of 4, I can knock out D. Now, I am crossing at 0. I am touching and turning back around at 1. And I am crossing at 2. So that gives me x minus 1 has to have an even exponent, right? When it's even, when your multiplicity is even, you're going to touch and go back. But when your multiplicity is odd, that's when you're going to cross your x-axis. So knowing the turning point and knowing your even odd multiplicity gives you that this has to be A. Do I have any questions on synthetic division? Okay, what about, do I have any questions on the remainder theorem and the factor theorem? That's just plugging it in, right? All right, so then I'm gonna jump down to 25 because that's where I want to spend the rest of our time at 25, 6, and 7. So 25, how do I find my rational potential zeros? What do I need to look at to find those rational potential zeros? Factors of P over my factors of Q. And you've got to remember that your first term is Q and your last term is P. So my factors of Q are 1, 2, 3, and 6. My factors of P are 1 and 2. So I need plus or minus 1 over 1. Plus or minus 1 over 2. Plus or minus 1 over 3. Plus or minus 1 over 6. My factor of P over my factors of Q. Now I got to do the same thing with the 2, right? Plus or minus 2 over 1, plus or minus 2 over 2, plus or minus 2 over 3, plus or minus 2 over 6. 1, 1/2, 1/3, 1/6. That took all of these to, I keep doing that. But I already have 1, don't I? And 2 over 2 is just another 1, so I don't need to use that one. 2/3. And then 2 over 6 is 1/3, which I already have, so I don't need to use that one. Now, am I saying all of these are my solutions? No. No, I'm not. As a matter of fact, if I look, how many positive solutions, I don't have it directly on here, but it's one of those things you need to use Descartes' rule and tell me how many positive solutions. How many times are my signs going to change? I'm positive, I stay positive. I go to negative, so there's 1 change. And then I go back. So my signs change twice. So I have 2 or none positives, right? What about, what would F of negative X look like? What terms would actually change their signs? Only when it is odd, right? If I have F of negative X, 6X to the 4th, because 4 is even, that's just gonna stay the same. But because 3 is odd, that's gonna change to a negative 3X to the 3rd. 2 is even, so that's gonna stay the same. And 2 doesn't have an X on it, so nothing's changing that. So I have positive to negative, there's one change, stays negative. Negative to positive, there's a second. So that gives me 2 or none negative solutions. And what would be your, excuse me, I'm sorry, what would be your maximum number of solutions you would have? What tells you your maximum number? Your degree. What's the degree of that polynomial? So your maximum number of solutions you can have, not that you will have. 2 of them will be positive or none of them will be positive. 2 of them will be negative or none of them will be negative. You're not absolutely going to have 4, but you possibly could have 4 solutions. Okay? All right, so let's take that much and look at 26. F of X let's determine how many positive, how many negative, and then what are my potential, give me a list of your potential zeros. Remember, your signs are only gonna change when you have an odd exponent. One change, stayed the same, and a second change. So 2 or none negative solutions. I know that I have a maximum of 3, so far that's fitting. Now it's nice when A is 1, because if my Q is a 1, then it just means that I need the factors of P, right? So it makes it a little bit nicer when A is 1. So my factors of P are gonna be plus or minus 1, 2, 3, 4, 6, and 12, right? All of my factors of 12. Now it makes no difference if you want to start testing your numbers with your factor theorem, or if you want to just go ahead and test your numbers with by doing your synthetic division. Either way works. I like to just start with the factor theorem because it helps me get through the ones that do not fit. So I'm going to start with testing -1. Make sure that when you do your testing, don't use f of -x. Make sure you go back and use your f of x, right? So if I have f of x and I'm testing 1, then I have 1 to the third plus 3 times 1 squared minus 4 times 1 minus 12. Now with that minus 12 on the end there, I don't think I'm getting to 0, am I? So I'm going to try -1, -1 to the third plus 3 times -1 minus 4 times -1 minus 12. I still have way too many negatives to get to 0. So I'm going to try 2. 2 to the third plus 3 times 2 squared minus 4 times 2 minus 12. That gives me a 4 plus 3 times 4 gives me a 12. That doesn't give me a 4, does it? Y'all, you are not paying attention to me. That gives me an 8, right? I'm gonna call that teacher out when she's wrong, guys. 2 to the third power gives me an 8. 3 times 2 to the second power gives me 12 minus 8 minus 12. Well, we cancel each other out, we get that 0. So I know that 2 is one of my solutions, right? So I'm going to go ahead and use my synthetic division. First thing I'm going to do is go back and check. 3, 2, 1, 0. I don't have any gaps, so I can go ahead and write in my coefficients. 1, 3, -4, and -12. So here we're doing the synthetic division. So if you had some questions on the synthetic division and didn't want to say so, that's what we're doing now. Wrote down, check to make sure I don't have any gaps in my exponents. I wrote down my coefficients. I'm going to divide by 2. Remember, you just bring that first one down. Now it's multiplying and adding. 1 times 2 gives me 2. 3 plus 2 gives me 5. 5 times 2 gives me 10. -4 plus 10 gives me a 6. 6 times 2 gives me 12, and negative 12 plus 12 gives me a 0. So now I'm on easy street because I have x minus 2 times. My coefficients are down there below that line. 1x squared plus 5x plus 6. Do I have to go back to my potentials and test another one? Or can I factor x squared plus 5x plus 6? What could I multiply to get a 6 that would add up to that 5? Good. So I have x plus 2 and x plus 3. So tell me about my graph, guys. What are my end behaviors on this graph going to look like? Up and down, right? We got my degree is 3, so it's odd. And it's positive, so one's going to be going up and then the other's going to be coming down. Where is it going to touch that x-axis? 2, -2, and -3. Is it going to touch or cross at these points? All of these have an exponent of, going to cross because all of those have an exponent of 1 and 1 is odd, right? Odd exponents cross over, even exponents touch and curve back. What's my y-intercept on this graph? That -12, right? Okay. Questions? All right, I'm good if you're good. Your test should have opened about 5 minutes ago. So it's up and ready for you. We are in class on Wednesday, so you guys will join remotely. We'll be looking at 6.1 and 2, starting those logarithms and composite functions. Friday at midnight. One shot. Make sure you are all ready. Don't wait till a stormy afternoon and say, oh, this would be a good time. Any questions at home?